Captions in English, please. So this is the third video on chapter 5, and this video will focus on naming type 2 ionic compounds. So type 2 ionic compounds contain a metal with a charge that can differ in different compounds. So we call them also variable charge metals. Example, lead can be Pb2 plus or Pb4 plus. Iron can be Fe2 plus or Fe3 plus. Depending on the compound, it can be one or the other. Such metals are usually, but not always, found in the transition metals section of the periodic table. So the variable charge metals are in the B groups. And there are some exceptions, as you know already. Silver, cadmium, and zinc are exceptions. These are type 1 metals. And the exceptions are also that you find some of the main group metals, such as lead and tin, from group 4A, bismuth from group 5A, are also forming more than one type of cation. So that's why they are not type 1 metals, but type 2. Since the charge of the metal cation in these types of compound is not always the same, the charge must be specified in the metal's name. So you will need to say in the name of the metal which ion it is. So we specify the charge with a Roman numeral in parentheses following the name of the metal. So the symbols are like that: Roman numeral 1, that's 2, 3, 4, 5. So 4 is 1 before 5, or 1 minus 5. And 6 is 1 more than 5. 7, 2 more than 5. 8, 3 more than 5. So this table shows you examples of type 2 metals, the most common ones, and their most common charges. So like chromium, it can be 2 plus or 3 plus, so that's going to be chromium 2 or chromium 3. So remember how the Roman numeral tells the charge on the metal. The table also gives you the order names that were used before the systematic way of naming them has been established. And so you may find those names sometimes, but we don't use those to have no problem identifying elements. We will use only the nomenclature that uses the Roman numerals. So iron can be iron 2, iron 3, cobalt, cobalt 2, cobalt 3, copper, copper 1 or copper 2, tin, tin 2 or tin 4, lead, lead 2 or lead 4. So these two are from the group 4A. Mercury is a special case because it can be mercury 1 or mercury 2, but mercury 2 has a 2 plus charge, and it's a regular way of having an ion here. But mercury 1 has 2 atoms of mercury bonded together, and those 2 atoms bonded together carry a 2 positive charge. So it's coming down to 1 positive charge per atom. So that's why it's called the mercury 1, you know, when it's that ion with 2 mercury bonded together. So the full name of this type of type 2 ionic compounds will be named by following this schematic. You name the metal from the periodic table. You take the name from the periodic table, follow it by the charge of the metal in Roman numerals in parentheses, and then finish the name with the base name of the anion and change the ending to "ide". So it's very similar to the type 1 ionic compound. The only difference is that you need to add the charge in Roman numerals in parentheses after the name of the metal. So let's look at examples of writing type 2 ionic formulas from the names. So when you're given the name like iron 3 chloride, the name tells you that iron is Fe3 plus in that compound. And chloride is a predictable ion. It's from group 7A, so 7 minus 8, it's a -1 ion. So Fe3 plus and Cl minus are the two ions that make up this iron 3 chloride. Next, you can do the crisscross trick, and you will have the 3 from the 3 plus charge of the iron go as a subscript for chlorine, and the 1 from the chloride ion will be a subscript for iron. So the formula will be FeCl3. Mercury 2 oxide. Again, mercury 2, the name tells you that it's a 2 plus charge on mercury. Mercury's symbol is Hg. The oxide ion is a predictable ion from group 6A. So you do 6 minus 8 is -2 charge on the oxygen when it's the oxide ion. So we have Hg2 plus and O2 minus. We can see that those two positive charges will be cancelled by the two negative charges, and then you get this formula of HgO. You don't really need to do the crisscross trick here. If you see that it's the same charge number, so then it cancels out by having one of each ion. Mercury 1 oxide. So be careful, mercury 1 is a special case. We saw in the table that it's Hg, 2 atoms, and then 2 positive charges. Oxide, again, is O -2. So this time you cannot do the crisscross trick. However, you can see that one of each will make a neutral formula, except that you have to take into account that there is 2 atoms of mercury, so it's Hg2O, and that's mercury 1 oxide. So be very careful with this one. You cannot do the crisscross trick, and it's a very special ion made of 2 atoms of mercury, carrying 2 positive charges altogether. So chromium 6 fluoride. Chromium 6 means Cr6 plus, and the fluoride ion from group 7A, it's 7 minus 8, it's -1, it's an halogen. So we have chromium 6 plus and F minus. Here you can do the crisscross trick and you will get CrF6, and that's chromium 6 fluoride. So naming binary ionic compound containing a type 2 metal. So you can determine the charge of the metal from the chemical formula of the compound and use the charge of the nonmetal to figure out the charge of the metal. So if you're given a formula, you need to use the anion symbol of the anion to find out the charge on the cation, on your type 2 metal. Because the sum of all the charges must be 0 for an ionic compound. And so, for example, the charge in iron, when it's in the compound FeCl3, must be 3 positive, because for the compound to be neutral, knowing that we have 3 chloride ions and each chloride has 1 negative charge, so 3 times 1 negative charge each, that's 3 negative charges in total, and they must be cancelled by 3 positive charges, and so those 3 positive charges will be carried by the 1 iron atom here. So that's how you find out the charge on the metal. So let's look at more examples here where we will write actually it's the name from the formula, not the formula from the name. So I fixed it. It's writing the type 2 ionic compound names from the formulas. So first example, CuCl. So let's find out the name. Cu is the metal copper. Cl is the chloride ion. So we know it's the base name chlor and with the ending "ide". The only difference here with what we have done with type 1 metals is that copper is a type 2 metal. It's in B group, and it's not an exception. So we need to find out the charge on copper using the chloride ion. There is one chloride, and the chloride ion has one negative charge. So because there is only one, there is a total charge, total number of negative charge of 1, and so we need one positive charge to balance the compound to be neutral. So that means the copper will need to carry one positive charge. And so in the formula, it's actually Cu plus and Cl minus together. And that means the name will be copper 1 chloride. Let's look at a second example, SnBr4. So the metal is tin, Sn is tin. It's again a variable charge metal from group 4A. Br is the bromine, and so bromine, you take the root of the name brom and change the ending to "ide", so it's going to be the bromide anion. The bromide anion has one negative charge, and since there are 4 of them in the formula, so that's going to be 4 negative charges in total. So the metal must carry 4 positive charges, and there is only one tin, so that tin will have the 4 positive charges on it. So the formula is actually made of ions Sn4 plus and Br minus. So the name will have 4 in Roman numeral, and so it's going to be tin 4 bromide. FeS3 is our third example here. The metal is iron. Fe is iron from B group, so it's again a variable charge metal. S is the sulfide ion. So from sulfur, you change the ending to "ide". And the sulfide ion has 2 negative charges. And there is 3 sulfide. So that means you have 6 negative charges in total, because 3 times 2 negative charges each, that's 6 negative charges in total. And so the 2 metals, the 2 irons here will need to carry 6 positive charges, because there are 2 irons, so you divide the 6 by 2, and that's going to be 3 positive charges for each iron. So in Fe2S3, you actually have the Fe3 plus ion and the S negative 2 ion. So the name will need to show the charge of the iron here, and so it's going to be iron 3 sulfide. So let's go through a concept check where you will pause the video and try to name or give the formula for the following, and then watch the answer after you've tried on your own. So nickel 2 oxide. Let's find the formula of nickel 2 oxide. So nickel is Ni, and here it says Ni2, so it's Ni2, the ion in that formula. Oxide. The oxide ion is a predictable ion. It's oxygen from group 6A. So 6 minus 8 is it's O negative 2 as an ion. Then you can do the crisscross trick, or you can also see that nickel has two positive charges, oxygen carries 2 negative charges, so together they will cancel out the charges, and one of each ion is enough to make the neutral formula, NiO. Because we always try to have the simplest ratio of subscripts, and the subscripts need to be whole numbers. Let's find the formula for molybdenum 6 fluoride. Molybdenum atomic number 42 in the periodic table. It's in group 6A, 6B. It's a variable charge metal. And the Roman numeral here tells you that it's MO6 plus. Then the fluoride is an halogen from group 7A, so it's F negative 1. So next you can do the crisscross trick, and the 6 from the molybdenum charge will be a subscript for fluorine, and the 1 from the fluorine charge will be a implied subscript of 1 for MO for molybdenum. So the formula is MOF6. Let's name CrCl3. So we have the formula CrCl3. Cr is chromium, Cl is chlorine, and the chlorine makes the chloride ion with 1 negative charge because it's an halogen from group 7A. And so chromium is in group 6B. It's a variable charge metal. So we will need the Roman numeral after chromium to indicate the charge of chromium in this compound. So you find the charge by using the fact that you have 3 chloride ions here. So 3 chloride ions, that means 3 negative charges in total in that formula. And so the chromium will have to carry 3 positive charges, right? So chromium needs to be a 3 plus ion to cancel the charges, so that the name then is chromium 3 chloride. Let's find the name of Ti2S3. Ti is titanium, atomic number 22 from group 4B. It's also a variable charge metal. S is the sulfur or the sulfide ion here. And the sulfide ion is carrying 2 negative charges because sulfur is in group 6A. So 6 minus 8 is negative 2. There is 3 sulfide. So 3 times 2 negative charges each. That's 6 negative charges in this compound. So the 2 titanium will have to carry 6 positive charges. And because there is 2 titanium, you do divide the 6 positive charges by 2. And so each titanium will need to be 3 plus, so that we can cancel all charges. So if it's titanium 3 plus, then the name is titanium 3 sulfide. Let's practice some more with this second concept check. Name or find the formulas for the following. And again, I want you to pause the video before you watch the answer. So practice. Try to find those names and formula beforehand. Okay, so the name of NaH. Na is sodium. It's in group 1A. It's an alkali metal. H is the hydrogen, but as a second in the name here as a non-metal, it's the hydride ion, so H minus 1. And so it's negative 1 because sodium from group 1A has 1 positive charge, so hydride has to have 1 negative charge. And so if you put those two together, because it's a type 1 ionic compound, right? Sodium is a type 1 metal, so then you just name it as sodium hydride. PbS2, let's find the name of PbS2. Pb is lead from group 4A, and that's a variable charge metal, so type 2 metal. S is the sulfur, or in this case here, the sulfide ion. And the sulfide has 2 negative charges because it's in group 6A, so 6 minus 8 is 2 negative charges for the sulfide. And we have 2 sulfide per formula. So 2 times 2 is 4. We have 4 negative charges in total. And so the the lead will need to carry 4 positive charges, and it's one lead, so the one lead will have the 4 positive charges. So it will show up in the name as a Roman numeral after lead. So lead 4 sulfide is the name of PbS2. COF3. CO is cobalt from group 8A, 8B, sorry. So that's a variable charge metal or a type 2 metal. F is fluorine or the fluoride ion. The fluoride ion carries 1 negative charge because it's in group 7A. So 7 minus 8 is 1 negative charge per fluoride. And you have 3 fluoride in this formula. So 3 fluoride bring 3 negative charges in this formula. So those 3 negative charges will have to be cancelled by the cobalt, and there is only 1 cobalt. So that cobalt will have to carry 3 positive charges. So we need to show that in the name by saying that it's cobalt 3 fluoride. Now let's find the formulas of manganese 2 iodide. So manganese is Mn, atomic number 25 from group 7A, sorry, 7B. It's a variable charge metal, and we see with the Roman numeral that it's a variable charge metal. And so in this compound, it has 2 positive charges. So it's Mn2 plus. And then the iodide is in group 7A, so 7 minus 8 is -1, so I minus. So here we are looking for a formula, so we can do the crisscross trick. And so the 2 from the 2 positive charges of manganese will become a subscript for iodine. And then the 1 from the negative charge of iodine will become a subscript implied for manganese. So the formula is MnI2, 1 manganese for 2 iodide. Cesium oxide, let's find its formula. Cesium is in group 1A, it's an alkali metal, so it's a Cs plus symbol ion. Oxide is O negative 2 because it's in group 6A, so 6 minus 8 is -2 charges for the oxide ion. You do the crisscross trick and you find that you need to bring the 2 from the oxide charges as a subscript for Cs, and then the 1 from the positive charge of cesium becomes a subscript for oxygen. And so the formula is Cs2O, 1 oxygen for 2 cesium atoms. Zinc phosphide. Zinc symbol is Zn. Zinc is an exception, even though it's in group 2B. It's not a variable charge metal. It's actually a type 1 metal because it's an exception. It's always zinc 2 plus. The phosphide ion is from phosphorus group 5A, so 5 minus 8, it's P negative 3. So you do the crisscross trick, and so the 3 from the 3 minus charges of phosphorus become a subscript for zinc, and then the 2 charges from zinc become a subscript for phosphorus. And so the formula is Zn2, Zn3 P2. Let me correct that. So the formula for zinc phosphide is Zn3P2, right? We crisscross the charges and they become subscript for the other element. And we can see that we need indeed 3 zinc 2 plus, so that's 6 positive charges will be cancelled by 2p, and each p has 3 negative charges, so that's 6 negative charges, and so that's a neutral formula.